In this video, I'm going to discuss about discrete probability distribution. In basic mathematics, a variable is represented by a small letter which represents an unknown value that can be calculated. For example, the equation y equals x plus 10. When x is equal to 1, then the value of y can be calculated as equal to 11. When x is equal to 2, then y is calculated as equal to 12. So the value of y can be calculated. So this kind of variable is called algebraic variable. In probability, the variable is called random variable. The value of the random variable is unpredictable and cannot be calculated. A random variable can take on a set of possible different values. Each value has a specific probability. Random variables are mostly represented by capital letters. The values of the variables are represented by small letters. For example, when a dice is tossed, let's say I use a capital letter X to represent the number of 10. So when a dice is tossed, it is possible a 1 is obtained. So X is equal to 1. Or maybe a 2 is obtained. So X is equal to 2. Or maybe a 3 is obtained, so x is equal to 3. Or maybe x is equal to 4, maybe x is equal to 5, maybe x is equal to 6. So generally, x can take on a set of value which is represented by a small letter x, where this small letter x is equal to 1, 2, 3, 4, and 5, and 6. The occurrence of the value is unpredictable. When we toss a dice, we do not know what number will be obtained. Each value has a probability of occurrence. So, x in this case is a random variable which is represented by a capital letter. Random variables can be categorized as discrete random variables and continuous random variable. We start from the discrete random variable. Discrete random variable has a set of possible values that are countable and can take on certain values within a range of values. For example, x represents the number of students who wear glasses in a group of 5 students. So in this group, maybe none of them wearing glasses, maybe 1, or maybe 2, or maybe 3 or 4, or maybe all of them wearing glasses. For sure, x is not equal to 6 because there are only 5 students in the group. So x has a set of possible values from 0 to 5. X is not allowed to take 1.5, 2.2, and so on. Next, if y represents the number of vehicles owned by a household. So in a household, maybe no vehicles owned, maybe 1 or maybe 2, and so on. So y can only take on an integer but not 1.4, 2.3, and so on. Now for continuous random variables. Continuous random variable has an infinite number of possible values, and it can take on any values within a range of values. For example, x represents the mass of a durian produced by a plantation. So x can simply take any value from 1 to 5. So x can take 1.2, 2.3, 3.45, and so on. And if y represents the height of an 18-year-old student, then this value of y can take on any values within a range from 1.4 to 2. So y can take 1.42, 1.755, and so on. These values of y can be obtained by measurement using a ruler. Now we proceed to probability distribution. What is probability distribution? We have learned that for discrete random variable, each value has a specific probability. If we list down all the possible values and together with their probability, then this is called probability distribution. Since random variable can be categorized into discrete random variable and continuous random variable, of course, probability distribution can also be categorized into discrete probability distribution and continuous probability distribution. In this video, I'm going to discuss the discrete probability distribution. The continuous probability distribution will be discussed in the next video. For discrete random variable, each possible value has a specific probability between 0 and 1. Under mathematical symbol, it is P. P represents the probability. X is the capital letter X for random variable. Small letter x is the value of the random variable equals P, where P is between 0 to 1. The sum of all the probabilities is equal to 1. Under mathematical symbol, it is sigma P x equals x is equal to 1. So this can be used to determine whether a random variable is a discrete random variable. Discrete random variable can be represented by using a table or by using a mathematical function. When using a table, this is all the possible values of x, and this is the probability of x1, this is the probability of x2, this is the probability of x3, and so on. The sum of all the probability must be equal to 1. When using a mathematical function, f(x) is the function of the probability, and all the possible values are listed on the right hand side here. The graph of discrete probability distribution is in the form of stick to show that the probability of each of the possible value. Now we proceed to the example. 3 black balls are mixed thoroughly with 4 green balls in a bag. Balls are drawn from the bag one at a time until a black ball is obtained. If x is the number of drawn performed until a black ball is obtained. Find the probability distribution of x. Verify that x is a discrete random variable. First, I'm going to use a B to represent the black ball selected, a G to represent the green ball selected. Since x represents the number of drawn, so definitely x must be started from 1, which means that the first drawn we got the black ball and stopped. Or x can be equal to 2, which means that the first ball is not black, which is green, and the second ball is black, so we stop at the second drawn. And x can be equal to 3, which means the first ball is green, the second ball is green, and the third ball is black, and we stop at the third drawn. And x can be equal to 4, which means first, second, third they are green, and the fourth ball is black. And x can be equal to 5, which means the first, second, third, and fourth are green ball, and the fifth selection is black, so we stop at the fifth selection. In this case, x is not possible to be equal to 6 because altogether we have only 4 green balls. So these are the possible outcome for the random variable x. Now we are going to calculate the probability for each of the value of x. When the first selection is black, so the probability is 3 over 7. When x is equal to 2, the first ball is green, the second ball is black, so it is equal to 4 over 7 times 3 over 6, which is 2 over 7. When x is 3, which is the first one is green, the second one is green, and the third one is black, so the probability is equal to 6 over 35. When x is equal to 4, first, second, third is green, and the fourth one is the black color, so the probability is 3 over 35. And when x is equal to 5, first, second, third, and fourth is green, and the third one is black color, so the probability is 1 over 35. So for the probability distribution of x, I'm going to list down all the possible values of x in a table and the probability for each of the possible values of x. So this is the probability distribution of x in table form. Next, I'm going to verify that whether x is a discrete random variable. If x is a discrete random variable, so the sum of the probability should be equal to 1. So now I'm going to sum all the probability. So when I sum all the probability and I found that it is equal to 1. So this means that x is a discrete random variable. Next example, the discrete random variable u has probability function given below here. Find the value of k. Hence, sketch the graph of the probability distribution function of u. Since we are given that the u is a discrete random variable and this is the probability function and these are all the possible values of u, so means when I sum all the probability, it should be equal to 1. So first, when u is equal to 2, so the probability is equal to 2 over 2k. When u is equal to 3, so when I substitute u with 3, it is 3 over 2k. When u is equal to 5, the probability is 5 over 2k. When u is equal to 7, the probability is 7 over 5k. When u is 8, so the probability is 8 over 5k. When u is 10, so the probability is 10 over 5k. And it should be equal to 1 because u is a discrete random variable. So when I calculate, so I found that k is equal to 10. Once I have got the value of k, so now I'm going to substitute the k into the distribution function. So this is the distribution function of the random variable u. Now to sketch the graph, I think it is easier if I can list down the probability distribution function in table form, where these are all the possible value of u, these are the probability. And I found that the denominator are different, so I changed the denominator the same. And again, I found that this value, I think it is easier if I put them in decimal form. So now I'm ready to sketch the graph. So this is the graph of the probability distribution of u, which is in stick form. And from the graph, we can see that when u is equal to 2, the probability is 0.1. When u is 3, the probability is 0.15, and so on. Next example, the discrete random variable x has uniform probability distribution given here for x equals 1, 2, 3, 4, 5, and 6. Find the probability distribution function of x. If x has uniform probability distribution, this means that for all the possible values of x, the probability for each of the value is the same, that is k. And we know that this is discrete random variable, so means the sum of all the probability should be equal to 1. So when we sum all the probability, it is equal to 6k. So therefore k is equal to 1 over 6. And in this question, we are asked to write down the probability distribution in function form. So under function notation, this is the probability, and these are all the possible values of x. Now we have learned the probability distribution. Then, what is so important about probability distribution? So actually, we can use the probability distribution to calculate the probability of certain event. So for example, if we want to find the probability of x in between A and B, so by using the probability distribution, then we can calculate the probability. For discrete probability distribution, if we want to find the probability between A and B, it is equal to sum of the probability of the values of x between A and B. Now let's look at this example. X is a discrete random variable with the probability distribution function given below here. Now find the probability of this question. First, to find the probability of x in between 2 to 4, included 2, included 4, which means that x is equal to 2, x is equal to 3, and x is equal to 4. So the probability when x is equal to 2 is 1 over 29 times 2 power 2. The probability when x is equal to 3 is 1 over 29 times 3. The probability of x equals to 4, it is equal to 1 over 29 times 4 power 2. So the value is equal to 23 over 29. Next, to calculate the probability of x in between 2 to 4, but not included 2, included 4. So which means that x is equal to 3 and x is equal to 4, but x is not equal to 2. So when x is equal to 3, the probability is 1 over 29 times 3. When x is 4, the probability is 1 over 29 times 4 power 2. So the answer is 19 over 29. Next, the probability of x in between 2 to 4 included 2 but not included 4, which means that x is equal to 2, x is equal to 3, but x is not equal to 4. So when x is equal to 2, the probability is 1 over 29 times 2 power 2. When x is 3, the probability is 1 over 29 times 3. So the answer is 7 over 29. Next, the probability of x in between 2 to 4, not included 2, not included 4, which means that x is equal to 3 only. So when x is equal to 3, the probability is 1 over 29 times 3, which is 3 over 29. Then for probability x in between 1.8 to 4.1, since the values of x are in integer, so means we are going to take the integers which is in between 1.8 to 4.1. So they are x is equal to 2, 3 and 4. So when x is equal to 2, the probability is 1 over 29 times 2 power 2. When x is equal to 3, the probability is 1 over 29 times 3. When x is equal to 4, the probability is 1 over 29 times 4 power 2. So the answer is 23 over 29.